Hey guys, welcome to the Code Pathshala. I am Roshan. So today I'll be discussing about the next part of rate limiter system design. So before discussing the next part, let's do a quick recap what we already have done. So the definition that we already have completed, after that benefits, then after where we have to put the rate limiter that we already have discussed, then all types of algorithm we discussed. If you have any doubt in these videos to understand the concept, please comment. And if you haven't seen this video till now, I'll put the link in the description. So please go to that link and check it out first. So let's start today's discussion. So the first thing that we will discuss about the rules. There is some rules which has been written in the config file. So we have to understand those rules first. How we can write the rules in the config file. So suppose if you want to allow only 5 marketing messages per day. So how you can write this in the config file? So to write these things in the config file, we have to write the descriptor for the rate limiter. So how we can write it? We can write it like this. So this is the format that we have to follow. If you can see this format, the first thing that we have to write the descriptors. So in the descriptors we have the key value pair. So the first thing would be key, then the second thing would be value. Key would be the message type, what types of rules you want to apply. The value will be the string like that, what types of value it would be. So in the rate limiter we have two things. One is the unit, so in which unit you want to measure these things, and the second thing that request per unit. How many requests per unit you want to allow. In the current example, 5 marketing message per day. So the key would be message type because you want to get the message. So value would be the string, what types of value you want. So here the value would be the marketing. You want to get the marketing message. So the key would be the message type and the value would be the marketing. So here we have to put the unit. How you will measure it? So here the unit would be day because you want to measure it in a day. And the request per unit, what is the rules? So you want 5 marketing message per day. So it would be 5. So if you can see these rules, it will completely show what types of message you have and what is the rules you want to apply it on. So what we have written here, 5 marketing message per day. So this is the rules. Let's take another example. Suppose if you want to allow the user to be logged in only 5 times in a minute, means user can log in only 5 times in a minute. So how you can write it? You have to write first descriptors, then you have to write the key. So what would be the key here? What types of rules you want to apply? So it could be like auth type. Previously it was message type because you want to receive the message, but here you have to do the authentication things because user are going to logged in. So it is the part of authentication. So it would be auth type. What could be the value here? So the value could be login because you want to check the login. Now the part is rate limit. So in rate limit we have a unit and then we have a rate per unit. What would be the unit here? Because you have to check in a minute, so unit would be minute. And what would be rate? So rate would be 5. 5 times in a minute you want to verify. So this is the rules, and these all rules are written in a configuration file, and this config file is stored in a hard disk. Anytime if any request is getting rate limited, the rate limiter will send the response code 429, which is too many requests. So this is all about the rules. So let's discuss the next part. So now we will talk about the detailed design of the rate limiter. So this is the detailed design. In middleware, you can see here the rate limiter is there. So what we are doing, we are writing the rules that we already have discussed right now. We are writing the rules in hard disk. So the rules will be written in the hard disk drive. Then we have the workers. So workers will get the rules from the hard disk and put it into the cache. So in that way, the rate limiter does not has to reach to hard disk. So the communication will be so faster. So this is the job of the worker. Worker will get the rules from the hard disk and put it into the cache. Then, so here we have the API server. Whatever the request is passed through the rate limiter, the request will come to the API server. Now we have the Redis. The rate limiter fetches the rules from the cache and it also fetches the data like timestamp and counter from the Redis. So here in Redis we have timestamp and we have a counter. So these data will be fetched from the Redis to rate limiter middleware. Then it will apply the rules, do the calculations, and then it will decide that either we have to pass this request to the server or we have to drop this request. So whenever the rate limiter will drop the request, means any request is rate limited, in that case we have two options. So rate limiter has two options. The option number 1 is it will drop the request and send back the response code to client, and the the response code will be 429. It means too many requests. What is the option number 2? Whenever any request is rate limited, rate limiter will choose the option number 2. If any message queue is available, means we implemented the message queue. So what it will do? It will put the request into the message queue. After some time, on the base of the FIFO system, the message queue will be passed the request. So whatever the request comes first, it will out first. All the requests which is rate limited, it will put into the queue, and then after some time this queue will be processed. So now suppose if you want to scale this rate limiter to the distributed environment, while you will scale it, you will face some problems. Let's see. So what we are doing here, we are just getting the data from the Redis. So suppose Redis will return here X. So in rate limiter, it is checking is this data exceeds the threshold. If it is, means suppose the threshold is Y. So if X is greater than equal to Y, if yes, then we don't have to do anything, and then request will be rate limited. Suppose if it is correct and it is passed, so in that case what we are doing, we are increment this data X plus 1. So see the problem. Suppose two threads, two concurrent request is coming at the same time, like this. So see, here the request 1 will come. So suppose the original counter equal to 3. So request 1 just gets the counter from the Redis. So the counter would be 3 and it will increment it. So before incrementing, request 2 comes and check the counter. So it will get the counter from the Redis, which is 3. Then after request 1, update the counter into the Redis, which will be 4. Here after that, request 2 will update the counter to the Redis, which will be 4. But it should be 5. So this is the issue. So this is the race condition. So we have a solution to fix this problem. The first solution would be implement lock. You have to implement the lock in between the requests. Whenever first request will come, it will lock the Redis, get the data from the Redis, then manipulate those data, increment it and put it into the Redis, and then unlock this one. So this process will take time. So it is slow. So while you will use lock, your performance will be degraded. So that is not preferable. So now you think that how you can fix this then. So you want to fix it and you don't want to degrade the performance. So for that you can use either the first approach is Lua script and the second approach will be sorted set of data structure that you can use. So if you are using the Lua script, in this case your performance will not be degraded and Redis will not support any other command while Lua script is running. It means Lua script will running in atomic mode. Now suppose if you want to scale your system for millions of users. So if you want to scale your system for millions of users, one rate limiter is not enough to handle all the traffic from those users. To fix those things, you have to use multiple rate limiter servers. So now let's take an example. Suppose if you have two rate limiter servers, rate limiter 1 and rate limiter 2, and suppose there are two clients, client 1 and client 2. So you want the client 1 should use rate limiter 1 and client 2 will use rate limiter 2. But it's not possible. It might the client 1 will use the rate limiter 2 and client 2 will use the rate limiter 1. So there is an issue because the rate limiter 1 does not have the data of client 2 and the same as the rate limiter 2 does not have the data of client 1. It doesn't have the data. So how you can solve this problem? This is a synchronization issue. So the one possible solution that you can use the sticky sessions. So if we use the sticky session, the client will send the traffic to the same rate limiter, but it is not advisable because it's not flexible and you cannot scale it. So now the point is that what you have to use. So the final solution would be that we can use the centralized data store like Redis. How it will be designed? Like client 1. So to fix those things, we can use the centralized Redis, which is the centralized data server. So the rate limiter will use the same Redis server, the second rate limiter will use the same Redis server. Both rate limiter will have the data of client 1 and client 2. So this will fix the issue and you can scale the system up to the mark, whatever the scale you want. So now the last point is monitoring. So while you are developing a rate limiter server, which is a huge scalable system, to develop those things you have to monitor your system. Why we need monitoring? So suppose if you are putting many rules, so some rules will so strict, in that case your actual request is getting rate limited, and sometimes you feel that your rules is not so strict, so many requests which should be rate limited, it is not getting rate limited and it is passing the rate limiter and reach to the server. To handle those things you have to implement monitoring, and while you will do the monitoring you have to put the log and matrices. So here Elasticsearch and Grafana will come into the picture. This is all about the rate limiter. So now we know everything about the rate limiter, how you can design the rate limiter, where we should put the rate limiter, should we put it at client side or server side or in the middleware, what all algorithms should be used for the rate limiter. Then detailed design, we already have discussed about that, and the rules, how you can define the rules of the rate limiter, and then why we need monitoring of the rate limiter server. So I'll put the link of the handwritten notes in the description. So if you haven't subscribed this channel, please subscribe it now. If you like this video, please hit the like button. So if you haven't watched the previous video, please go to the previous video, which is part 1 and part 2 of rate limiter. So I'm signing off. Thank you. Bye bye.